Welcome to Techstination. Joining us is Brian Hemond, the CEO of a company called Indigo Technologies. Thank you for joining us, Brian.
Well, thank you for having me.
Tell us about Indigo Technologies. Really fascinating company doing some great stuff. Been around a while, but just came out of stealth mode.
That's right. So Indigo Technologies was founded back in 2010. Our founding professor is Professor Ian Hunter at MIT, and he really founded the company with the intent of making strides towards improving efficiency of transportation and making an impact on global pollution, essentially.
I guess you could say you've invented a better wheel at the company.
Exactly. Yeah.
Tell us what you've done, what all this work has
So
been about.
Sure. So we've been looking at cars and vehicle architectures for really quite some time now. And what we've come to believe over the past 10 years is that one of the key problems in being able to improve vehicle efficiencies is actually the design of the vehicle itself. So if you look at your average vehicle on the road today, most of the energy goes into pushing the vehicle through the air and overcoming the rolling resistance of that vehicle as it's traveling over the ground. So to really make dramatic improvements on the efficiency of that vehicle, you've got to make the thing more aerodynamic, and you've got to make the mass significantly lower. And that's just not something that's really achievable with conventional powertrains. Vehicles basically have 100 years of history of being built over the conventional internal combustion engine, and more today, built around that centrally mounted electric motor. But what you end up with is a vehicle chassis design that can't really be shrunk because you've got to package the people who don't shrink in along with those sort of traditional driveline technologies. So what we've done is develop an in-wheel motor system that now moves that powertrain outboard, which gives you a lot more freedom in terms of the cabin volume, cabin geometry, and a lot more freedom in where you can now put that person, which actually overall ends up making a much lighter weight vehicle, and a vehicle that's much more easily to be designed around the aerodynamics and optimizing those vehicle aerodynamics.
Do you have a name for this? The in-wheel Traction T1 Propulsion system.
That's correct. And so, if you look back at the history of in-wheel motors, in-wheel motor technologies have been tried actually nearly since the beginning of automated vehicles, back almost for 100 years now. What we've done is now put that electric motor into the wheel in such a way that that wheel now has an added functionality. So that wheel is able to provide an active suspension simultaneously as it's able to provide the propulsion for the vehicle. And what that does is now make it so that smaller vehicles can essentially ride more like larger vehicles. They feel more comfortable. They can address some of the challenges that are coming with autonomy, and effectively make them more palatable, so that people don't feel like they have to be driving around in a 2,000 kilogram steel box just to get to work.
What do you mean by helping to address some of the challenges of autonomous vehicles?
So if you look forward to the what we think is coming down the road, autonomy and autonomous ride sharing, you'll see that one of the key issues is that as soon as people get into these vehicles, the first thing they're going to do now is pull out their laptop or their cell phone, sort of as they do on automated trams around airports today. And one of the immediate issues you see as soon as people are looking at their smartphones instead of looking out the window is that they are very susceptible to motion sickness. And this is a fairly well understood problem. I think it's something that certainly the airlines and the rail systems have been dealing with for many tens of years now. And effectively, the only way you can now address the motion sickness issue is to know where that vehicle is going, which is easy when you're on a rail or in the sky, and you sort of lean that vehicle into the turn to sort of give the body, the person's body, a sense that a turn is coming before you now have that turn coming on, which sort of forces a disconnect between what they're seeing and what their body is experiencing. So if we were all to suddenly get into autonomous vehicles tomorrow and be driving down the road and subject to all the turns that, especially here in Boston, you end up careening through every day, motion sickness is going to be a significant problem as autonomous vehicles start to take over for the sort of daily commuting needs.
And this alleviates that to a great extent, or?
To a great extent, yeah. I mean, it's rare that people still do get motion sick on trains and planes, but it's a much lower incidence than it is certainly before some of these techniques were discovered. And even now, people can be motion sick in cars, especially when they're not in command of that vehicle and missing some of the cues that they would get by maybe seeing the driver turn the wheel, et cetera. But being able to lean that vehicle over as it's going into a turn is really one of the only ways that you can even begin to address the issue, because otherwise you have no way of providing inertial cues to the person who's is a passenger in that vehicle.
Well, tell us about what other advantages there might be, whether it's efficiency, driving range. If we're talking about all electric, what do you think some of your advantages are here?
So really what we're getting at is trying to push vehicle design towards smaller and more efficient vehicles. Basically, we look at transportation today, and we see that vehicles are too big. They're not really ideally suited for even the ride sharing transportation methods we're seeing now. Most ride share vehicles have maybe just over one passenger on average in them, and it's crazy to be driving around a 6-person SUV to get someone to work. So efficiency is really the key that we're aiming at here. We're trying to make this motor basically underpin a whole new class of vehicles, something that can now be small and efficient and lightweight and aerodynamic, such that the energy costs of moving that person from point A to point B are greatly and radically reduced. We're not talking incremental gains, the way that regulation is sort of pushing the industry with a 5 or 10% type gain over the years, but we're talking 10 times gain, 100% change in the energy that's being used for vehicles. So what we're doing by building this motor is making it possible to build these vehicles and have the advantages that you would otherwise want in your larger vehicle. So a more comfortable suspension, being able to run over potholes and things, while maintaining that very lightweight chassis. Because if you look at, going back to like an SUV, one of the reasons you don't feel the road as you're cruising down the road is that your 2,000 kilogram vehicle hits a pothole and you weigh 60, 70 kilograms. You're a fraction of the mass that's driving down the road in that system. We're trying to make it so that vehicles can be on the order of 200, 300 kilograms, where the person's now a significant fraction of that overall vehicle mass. And that poses some challenges when you're trying to now isolate that person from the road that's going by, and that's really where the active suspension piece comes in. And active suspensions, the concept is not new, but what is really radical about the design of our motor is that you get that active suspension effectively for free. It's the same system, same magnets, the same coils of wire, et cetera, in the motor that produce both the driving force as well as the active suspension. So we're trying to make the cost of that overall system be relatively small compared to the benefits that you get out of it. Because to us, if we can't start to produce the technologies that really bring down the mass and improve the aerodynamics of cars, we're going to run into a significant energy crunch sometime in this century, certainly.
Whether these are electric vehicles or not.
Exactly. I mean, you look at a conventional electric vehicle on the road today, and the mass is sometimes heavier because of the onboard battery system, and the aerodynamics are no better than their gasoline counterparts. So you're able to share in the benefits of electrical generation at scale, and to some degree the renewable electrical generation systems we're starting to see put in, here in the U.S. especially, and overseas as well. But those gains are incremental. The vehicle itself, the energy used to push that vehicle down the road is roughly the same between the gasoline and the electric versions. It's just that the electric energy is available more efficiently.
Tell us about the plans to bring this to market. Are you having talks with potential partners here?
Absolutely, yeah. So we're talking to a number of different partners. Of course, we're looking at the the more traditional OEMs. Of course, there's some interest there, but of course that takes a fairly radical change in thought in terms of the design of the vehicle. So that's going to be one of the slower roads forward. But there's a number of other companies that are trying to sort of rethink transportation with us, whether it's sort of a municipal type system where you're now talking about public infrastructure that can alleviate some of the congestion issues, or the fleet type operators, the people who'd be doing ride sharing, as well as the delivery services. People that own large fleets of vehicles that have fairly predictable routes are obvious cases for the adoption of extremely efficient vehicles. Your fleet costs go down, and that's noticeable much more quickly than the sort of personal ownership model where you're trying to compare the relative costs of an electric vehicle versus a gasoline vehicle.
How do you deal with the battery issue? Do you need less battery, less weight than the traditional electric vehicles?
Yep. So there's a couple of nuances here. First of all, if you are able to shrink that vehicle down, the battery capacity needed to move that vehicle becomes lower, and conversely, the time it takes to charge that smaller battery with today's chargers also goes down. So you can regain that range more quickly as well. A lot of things sort of move in a favorable direction once the mass of that vehicle comes down and the aerodynamics go up. We are also, cognizant of the fact that, of course, anything we can do to improve the efficiency of the mechanical systems on board that vehicle will only sort of extend the range of the energy capacity that's on board. So we've made some specific design choices in the design of this in-wheel motor to make sure that it can capture energy from regeneration as well as running over potholes and bumps as efficiently as possible. And we've basically done that by eliminating sources of friction, eliminating gear trains, et cetera, in the design of that motor, so we can very rapidly capture energy, whether it's from braking or hitting potholes as well. So we're trying to extend the range in that regard as well.
What about the expense here? How affordable do you think vehicles using your technology can be?
Yep. So of course that's one of our keen interests is making sure that this technology is inexpensive enough to be adopted. And again, one of the key pieces is that if you're now shrinking a vehicle down, the demands on that motor become much lower as well. So you can use the same amount of power will get you much more acceleration if the vehicle is much lighter to begin with. So we are also very cognizant of the fact that we have to avoid putting any exotic technologies in to get any of these to get these benefits. So most of the core of this motor is really built off incremental gains in motor technology that we've seen over the past 100 years. It's the way those components are arranged and the way they're linked together that gives us this added functionality. So ultimately, we don't think that the cost of the motor is going to be any more significant than a motor of equivalent power, whether again it's a combustion engine or an electric motor.
What do you think the time frame looks like, the roadmap, so to speak, as far as getting these out there?
Yeah, so we're in the middle of commercial discussions right now. We are basically with the public face of the company coming out last April. We strongly feel that we're now ready to start producing these motors and getting them out into the market. So, the technology is something we've proven to our satisfaction internally, and we're ready to demonstrate. And we're actively working to now integrate these into upcoming vehicle designs. Of course, that cycle tends to be, years at the short end, but we're doing everything we can to make things move a little more quickly.
For more information, where's the best place to go?
Our website's a great place to start. It's indigotech.com, as well as our social media feeds are updated regularly as well.
Again, that's indigotech.com, and we're really looking forward to seeing what's next. Brian Hemond, thank you for taking the time with us.
You bet. Thank you very much.
Now this. Innovation. Hi, I'm Fred Fishkin, and I've been covering consumer technology for a long time, and it takes a lot to impress me. That's why I'm excited to tell you about the latest way to enjoy cooking in the great outdoors from my friend Patrick Sherwin and his great team at GoSun Stove. What if you could harness the sun to cook your meals anywhere you go, day or night? The GoSun Fusion arrives this summer using the company's tried and true reflectors and a solar vacuum tube to get you cooking without the mess of charcoal, heavy propane tanks, or smoke. And with an optional solar panel and battery storage, and the ability to plug in at home or on the road, you really can use the GoSun Fusion to cook anytime and anywhere. Want to learn more? Head to gosun.co and use the code Techstination to save 10%. That's gosun.co.